All right, which question you guys have? Okay. All right, 69. The question 69 says log x plus log of x squared minus 1 minus log of 7 minus log of x plus 1. So what happened is this log, this two is adding together. This two is adding together, so it'd be log of x times x squared minus 1. Because this is adding together, so it means multiplying together. Minus log of 7 minus log of x plus 1. So now this is minus. You still you do one piece at a time. So it'd be log of x squared minus 1 over 7 minus log of x plus 1. And that's going to be log of x times x squared minus 1 over 7 times x plus 1. You can probably simplify this. I don't know which kind of answer they have, but you could have x plus 1 and x minus 1 because that's a factorable. So that can probably simplify down to log of x times x minus 1 over 7.
So on the test, do you want it completely factored out and everything? Or are you fine with
Combined into one log. They will say condensing or expanding. Next questions. No more questions? Yes. 67. It's a 1/3 2 natural log of 2x plus 5 minus natural log of x minus natural log of x squared minus 4. Now I'm going to do inside first. What happened? It's 2x plus 5, right? 67. Oh, it's 2. Oh, it's x plus 5. Okay. So now I will combine this two first. Well, first of all, I will make sure that it's going to be natural log of x plus 5 squared before I combine. Sometimes you guys are so lazy, just write down one step. You guys need to learn to slow down, write down all the steps first, and then you guys can skip step. Usually it's not. So x plus 5 squared over x, because divided minus x minus natural log of x is minus x, divided by x, minus natural log of x squared minus 4. And now go ahead and do that again. So 1/3 natural log of x plus 5 over x times x squared minus 4. Now that's done. I'll put a 1/3 on the top. So be natural log of x plus 5 over x times x squared minus 4. And this is going to be 2/3. And that will be the final answer. And that's your test question right there.
X plus 5 squared.
X plus 5 squared. Yep. Next question.
46.
46. Okay, 46 says log 3 of 405 minus log 3 of 5. Now, it's subtraction, so it's division. So log 3 of 405 divided by 5. I have no idea what is that. 81.
Yeah.
So log 3 of 81, so that's equal to 4. That means 3 to the switch power is 81. Any question that you have for expanding, like 38 or 39 or 37 or 29? That 29 is actually a good question. It's easy question, but it's hard question at the same time. Yes,
I'll go over to the right.
29, sure. So if I say log, what kind of log is this? What kind of base is this?
Or just 10.
10. So I'm gonna rewrite it to like this. X to the 1/2 power. I'm putting it in front. And I'm gonna have 1 log 10. This is a multiplication, so it becomes addition. So it'll be 100 plus log 10 of x. And that's equal to 2, because 10 to which power is 100 plus log 10 of x. And then that's gonna become 1 plus 1/2 log 10 of x. And that will be a final answer here. This is actually a very good one.
If you remember, if you get the square root of 100, take it out, and it's 10 times the square root of x, and then you split it, and then you just get a 1, and then the 1/2.
Yep,
Okay.
it's fine. It's just order operation. You change it a little bit different. Next question.
The base and so it's going to be so
No more? Yeah?
36.
36, sure. That's a good question. Log 2, fifth, x y to the 4 of 16. First of all, what kind of power is that? What kind of power is that? Fifth? 1/5 the power, right? And that should be expanded to the front. And then just have to do 1/5 of log. This is times each other, so it'll be x plus 4 log of y, because that y is from here, drop down in the front, minus log, wait, what base is this? 2, I just need to write down 2. And this is 2 of 16. Which is log 2 of 16 is what? No. Which one is it? 2 to which power is 16? Why you didn't go through the process when you say it? You cannot do that. You have to process. You guys need to learn to slow down, process before you say it out loud. It's like you asking little kids like how to add 3 plus 5. They'll be like 6. And if you got it wrong, it'll be like 7. If you got it wrong, they go to 8. That's not a key. Take a pause, think about it. Think about 2 to which power is equal to 16 before you tell me what the right answer is. So that is going to be 1/5 log 2 of x plus 4 log 2 of y minus 4. And then you can distribute. So 1/5 log 5 x plus 4/5 log 2 of y minus 4/5. On your test, you need to learn how to slow down, think. Rather than go fast, make mistake, you get all the points taken off. You take times when you're doing things. I don't know if you watch Cars, like Lightning McQueen. What was that phrase? In order to turn right, you have to turn left first. When he trying to make that turn, when Lightning McQueen cannot make that turn. So you guys have to learn to slow down before you get faster. Slow down, do it perfectly, and then you can get faster. That's the key. Is always that way. You learn how to play piano. You learn at first. You learn slow, and eventually it gets faster and faster. But you're not straight up to become fast because there's no way you can do that. Slow down and think. Last few questions I want to go over because that's a changing base equation. You can use calculator. So this, you can type in. Now remember, this is log of 13 over log of 5, or natural log of 13 over natural log of 5, but not log of 13 over 5. They are different. They are completely different things. So you can use calculator, type in the calculator. See, if you type in the calculator, say log 13 divided by log 5, that's your answer. Because that's called changing base. The big one divided by the small one. But they are log. I'll tell you the answer. Log 5, 13. So try it. But you can try natural log too. So try both. So I want you to try both. This one is, I don't know, this one's log. This is a 1.1139. And by log, that's 0.69897. And it'll be 1.1139 divided by 0.69897. It should be 1.5936. And you can try this one. It should come out exact same number if you're using a calculator correctly. And that's a very powerful formula. It's called changing base formula. I see on multiple choices one question like this. I was like, this is probably the easiest question you can think of.
If I just put like log 5 with 13, I just have that, or should I do
No, you have to have. Austin asked a really good question. Can you do log 13 over 5? No. You have to be log of 13 divided by log of 5. They both, there's two log there. There's log for the numerator and log for the denominator. I prefer use natural log just because I use natural log more often on AP exam. I don't really use log. So I actually prefer the natural log one. And it's also, you write one less letters, but it's not gonna save you more than 1 second, but still. That's the one I use because there's a button that says natural log. They are where the either X button is. They are the same button. So learning how to use calculator. How many of you guys still don't have calculator? 1, 2, 3. Robert can afford it. Get a 1. Cohen, can you buy one or no? Okay, Jay. Okay, so I'll find a way to get you one. But the problem is, and also I just found one yesterday for like, instead of $130. Like I know Ashton found one for like 30 or 40 bucks. That's very rare. I found one for 70. It's brand new. But somebody in calculus want to buy it, so I usually go meet a person, I buy it, and I come back here, and you just have to bring me cash to buy it. But That's a lot cheaper than buy a new. That calculator basic new, but it's good to have a calculator for SAT. So, and it's better to have the graphing one and non-graphing one. Although I don't know, I think in the future probably you can not use that. All right. So let's talk about solving equations. Logarithm equation. Today I'm going to give you some more practice of those questions. Remember, all those questions on the test. So this is the question. This is one we did before. How do I solve for x? I see some good keywords. Austin says, I can change base. Do you see this base? They have something in common. 2 and 16. What do 2 and 16 have in common? Base of 2, good. So I can rewrite this 2 to the 3x minus 8 over 2 to the 4. We talked about this beginning of the year. Since they both base of 2, I can actually do log 2 on both sides to get rid of that 2. Technically, that's not what happened. But since they both base of 2, I can set top part equal to each other. So it'll be 3x minus 8 equal to 4. 3x equal to 12. X equal to 4. I can solve for that. So can you do this one? This is on SAT. Sometimes there could be a system equation embedded to these questions. You have to recognize it. There's actually, on the October SAT has two, a lot of questions are exponentials. A lot of them has to do with the radioisotopes, which is chemical decays. Something like sodium's decay, sodium 21's decay at this speed, and blah blah blah. It has a lot of that. We're gonna talk about that tomorrow if we have time. You guys got it? What's 27 and 81 in common? Base of 3, good. So now this is the base of 3. So instead of write down 27, I can write down 3 to which power? 3, but put a parenthesis outside like this because they are multiplying. Because they are multiplying here. Now this is going to be 3 to the what?
4.
And at the beginning of the year, we already talked about this. And that's going to be 2x equal to 11, x equal to 11 over 2. Hopefully you get that. We talked about this beginning of the year. This is good SAT questions. You're going to have some homework practice on this. This is just beginning of the year. I probably give you like something even like, instead of 81, I probably give you 1 over 81. What's the difference between 1 over 81? Negative exponent. Good. So now you're thinking. Processing before you say it. Processing. What kind of rule I'm thinking? This is actually 3 to the negative 4 power. I can change that. You got to adjust that. I can even square root 81 or whatever. But here is where it's different from this section. 4x equal to 15. There is no way for me to change into common base. You got 4 and 15. Do they have a common base? No. So now you're going to utilize the natural log. I don't write down log anymore, even though log going to get you same answer. But I'm going to use natural log both sides. So I'm gonna use natural log on both sides. Remember, you can do something to the both side equation. And I think this one is natural log of 4 to the x equal to natural log of 15. Why do we use natural log? Why we natural log both sides? McKenna? I don't think you answered that question yet, Brendan. You can bring down the exponent. The key thing is this. This is a known, right? This can bring down to the front, so be x natural log of 4 equal to natural log of 15. And all I gotta do is solve for x. If I solve for x, guess what? Natural log 4 on both sides, and x equal to natural log 15 over natural log of 4. There's a second way to do this question. What is the second way? 4 to the x equal to 15. I can draw a heart. So be log 4 of 15 equal to x, right? That becomes the logarithm form. If I have logarithm form, can I just use change in base here? But remember, it's two natural log. It's natural log 15 over natural log 4. They are not equal to each other. Please do not say this. They're not the same. So make sure they're not the same. Does that make sense? You can bring the power down. Got it? The simple one I can give you to practice, which is, I don't know. Like 5 to the x equal to 17. And you can solve for that. Fairly easy. You can do it both ways. It should be done like very shortly, like 10-20 seconds. I love logarithm. It doesn't take long. It's just very intimidating when people see natural log and log. But the operation is actually easy as algebra there is. Okay, so we're gonna solve this question. 40e to the 2x minus 3 equal to 10. Something like this. And we're gonna solve for x. So solve for x. What do you do first step? Move the 3 over, good. Why are you doing that? To isolate, yeah. You usually solving equations isolate. What do I do next? No. You gotta isolate. Still. Divide by 40. So you have to divide by 40. You don't do natural log both sides. So that's e to the 2x equal to 13 over 40. Why do you do natural log on both sides? What?
No common base.
Yes and no. That's not wrong answer. Yes. Yes. You get rid of e because natural log and e are inverse to each other. Remember that rule says log of 2, this is inverse to each other. So imagine that I can use natural log because natural log is equal to what? Log base e. But base e and e would cancel, which is e to the 2x equal to 13 over 40. Cancel out. 2x equal to 13 over 40. And then it's going to be natural log of 13 over 40 and divided by half. So it's going to be x. Ian, did you write stuff down or you just stare at your iPad? Because later on, you're going to be like, I didn't know how to do it. You're going to show me that one. I'm going to give you 0 credit from now on the homework, because that's not going to cut it. You isolate. Okay. Okay, so I want you to solve for this one. Very simple. Check each other when they're done. You guys should be able to do this. Next one's a little bit more complex. Oop. Let me rewrite again.
Could you zoom in?
You guys should get the same answer. You isolate the e. You divide it by 4. You can natural log both sides. This will cancel out. 4x equal to ln of 11 over 4. Now that's one natural log there. X equal to 1/4 ln of 11 over 4 because I divide by 4. I divide by 4 is in the front, not inside the argument. So hopefully you guys get the same. Now this one's interesting. Anybody can provide me an idea how to solve this one? What does that look like? Yes, Armin? No. Somebody say something else. Y factor.
Because it's set equal to 0, and the exponents match up to its history, so like x, and then no x.
See, that's a really good idea. And this is a box method. Why is box method better than any other method? Because this shows that really, really good. Which two things multiply each other is going to be e to the 2x? E to the what? E to the x. Good job, Merle. 3 and 1. This is going to be 3e to the x. This is 1e to the x. Which one need to be negative? Both. Good. So it'll be e to the x minus 1 times e to the x minus 3. Now, since they're equal to 0, I'm glad that she pointed out, is equal to 0, then I can factor it. And that is probably the most important idea. Can I scroll up? Now I can set them equal to 0 because 0 product property, right? So can I set e to the x minus 1 equal to 0, e to the x minus 3 equal to 0? Can I isolate the 1? Now what do I do next? ln of 1, ln on both sides, ln of e, so x equal to ln of 1. What's ln of 1? 0, good job. What's ln of 3 will just cancel out. X equal to element 3. There are two answers. There are two answers. Does that make sense? You can factor. How do I solve this? How do I solve this equation? Log 4 of x plus 3 equal to 2. Any good idea here? Robert?
Did you split up the log?
You cannot split up the log because it's a plus. But it's not log 4 of x plus log 4 of 3.
You're right. What did the session power equal to x plus 3?
Yep. Draw heart. This is a very popular ACT questions. Draw heart. Because it's logarithm form, I can always convert to exponential form. 2. Nope, sorry. 4 to the second power equal to x plus 3. And that's 16 equal to x plus 3. And x equal to 13. And that's it. If you plug in 13, what'll happen? 13 plus 3 is 16. Log 4 of 16 is equal to 2. How about this one? What can I do here? Raise your hand if you do. No.
Could you combine the two logs and
Ver-
then do the hard?
Yeah, so you just learning all the tools from before, right? X times x minus 7 equal to 3. And then she says, can I do hard? Of course. That's going to be x times x minus 7 is equal to what? 2 to the third power is what? 8. But what do I do next, though?
Or you distribute the x, so it's x squared minus 7x, and you move the 8, and you copy.
Exactly. You have to make sure equation is equal to 0. It cannot solve like this, x equal to 8, x equal to 1. No, that's not true. You have to make sure set equation equal to 0, because you can use the property now. That's just a... But only thing you have to make sure is this. I'm going to show you in a second. This is x. I believe this is x minus 8 and x plus 1. And x equal to 8, x equal to negative 1. Now, those are extraneous solutions here. Which one is extraneous? And why? What?
-1.
Why?
Negative.
You haven't explained me why yet, but you explain me it's negative. But why is negative not allowed? Type in the calculator. Type in logarithm of -1. Yes. Because I said factor x minus 8 equal to 0, x plus 1 equal to 0. And I move the 8 to the other side. Can you log a negative number? No, it just show you error. So this is undefined. This is called extraneous. And this is the only solution. Today's homework, I'm gonna post answers. You're gonna try to get the answers. I'm gonna post some homework from before to get you master the condensed and expanding. Today you really had to utilize that. Yes.
So it'll only ever be extraneous if it has a negative? Or
Yeah, you cannot have log of negative number. Radical is fine, but long as you don't have a log of negative number, because a graph of natural log is this way. There's no negative numbers. You guys have test on Thursday.